we're going to take a look back at some limits properties. Okay, first we're going to take a look at how to find limits graphically, which is something we've already learned, but today we're going to take a look back at how we do this. Okay, big thing to remember when we're looking at a graph trying to find a limit, we have to make sure that y is approaching the same value as we approach the x value from left and right. So that's what we're checking. The left and right hand limits, are they the same? If so, the limit exists. If not, the limit doesn't exist. So let's take a look at part A. For this graph, we want to find limit as x approaches -5 of f of x. So let's take a look as we're approaching -5 from left and right. As we approach -5 from the left, notice that we are getting smaller. Okay, we are going down towards -infinity. As we approach -5 from the right, we are getting larger. Okay, it's going up and up toward positive infinity. So I was trying to, there we go. Pen's working now. Okay, so now we can tell that we're approaching two different values. And since we are approaching two different values from left and right, this limit does not exist. Okay. If we are approaching the same direction, then we could say positive or negative infinity, depending on which way we were going. But because they're approaching different directions, the limit does not exist. Limit as x approaches -1, notice that as we come from left and right of -1, we're approaching the same value, which is 6. So limit as x approaches -1 is 6. Limit as x approaches 3, notice from left and right, we are approaching the same value. Okay. The circle is not filled in. We have a hole in the graph, but that's okay. It doesn't matter if the point is not defined. What we're worried about is, does the limit exist? So we're just looking at what y is approaching. It doesn't matter if it gets there. We're just looking at what y approaches. And so since from left and right, we're approaching the same value, which is 3, the limit from the left and the right are both 3. So limit as x approaches 3 is 3. Next, limit as x approaches negative infinity. So we want to think about as x goes to the extreme left, okay, so as x is approaching negative infinity would be as x goes to the extreme left, what's happening? Well, we have an asymptote there. This is going to get closer and closer but never reach the asymptote. Where is the asymptote? It's at -2. So limit as x approaches negative infinity is -2. Take a look at the right side of our graph. Right side of our graph, limit as x approaches positive infinity, we have the same kind of thing going on. Okay. We are approaching that asymptote. We're never going to get there, but we're always going to be approaching that value, which was -2. Okay, so again, biggest thing for graphical limits is we have to make sure that we're approaching the same value from left and right in order for the limit to exist. All right, let's take a look now at limits algebraically. Okay, we have three big things that we have to remember as far as how to evaluate limits algebraically. First, we want to attempt to plug in the number. We love those. Those are easy when we can just plug in the number and evaluate. If we cannot do that, we want to try to factor or cancel something out and then try plugging in again. Okay. Sometimes it's very easy. It's a quick factor, cancel, plug in, we've got the limit. Now, if we've tried both of those things and we cannot plug in still, we only have 3 possibilities. We could have positive or negative infinity or does not exist. That's the one where we pick something 0.5 to the left and 0.5 to the right, plug in, see what sign we get. Okay, let's talk about these. We have 5 examples here for you to take a look at. Example A is a nice one because we have just a regular polynomial, so we can easily plug in the number. Okay, if we plug in limit as x approaches 2, so we're going to plug in 2. 2 cubed minus 2 squared plus 6 is going to give us 10. 8 minus 4 plus 6. So again, we like those. Those are easy when we can just plug in and evaluate. Part B, limit as x approaches -2, we are going to have to cancel because if we try to plug in, notice that we're going to get 0 over 0. Now, it's not a big deal if you get 0 on the top. The problem is if you get 0 on the bottom. We want to try to factor and cancel out. So if we have x squared plus x minus 2 on the bottom, we can factor. That would be x plus 2 and x minus 1. x plus 2's would cancel, and we'd have 1 over x minus 1. If we now try to plug in negative 2, we've got 1 over negative 2 minus 1. 1 over negative 3 would be negative 1/3. That would be our limit. For part C, we're going to have to factor again. Can't plug in 5 because we'd get 0 over 0. So if we factor the top, that's a difference of cubes, which would be x minus 5 times x squared plus 5x plus 25. On the bottom, we would have x plus 5, or excuse me, x minus 5, and x plus 2. The x minus 5's cancel out. Now we can plug in 5. On the top, we would get 75. On the bottom, we would get 7. Doesn't reduce, so 75 over 7 is our limit. I would suggest you go back and look at sum and difference of cubes formulas if you don't remember those. Part D. If we try to plug in negative 4, we can plug it in on the top just fine, but if we try to plug it in on the bottom, we're going to get 0. If we try to factor, the only thing we can do is take out a 4 on the bottom, and that's not really going to help us because we still get 0. We can't cancel anything out. So this is one where you want to plug in 0.5 to the left and 0.5 to the right. So let's try negative 3.5 and negative 4.5. Now, we're not interested in the actual number. We only care about the sign. So if we plugged in negative 3.5, we'd have a positive over a positive. We'd get a positive answer. If we plugged in negative 4.5, we would have a positive over a negative, which would give us a negative answer. So at this point, those signs are not the same. We have a positive, we have a negative, so this limit does not exist. If you think about what's happening graphically, we have an asymptote at negative 4, and what this is telling us is that as we get closer to the asymptote, we're going in different directions, kind of like we did with the graph that we saw earlier. Last one. As x approaches 0, we've got 3 over x squared. We cannot plug in 0. We cannot factor. We cannot simplify. So we just need to do 0.5 to the left and 0.5 to the right. So negative 0.5 and positive 0.5. If we plug both of those in, we're going to get a positive because of the x squared. So that means this limit is positive infinity. All right, let's take a look really quick at some special trig limits. These were ones that you just needed to memorize. You have to know those because you will end up having to use them quite a bit with trig limits. First, limit as x approaches 0 of tangent of x over x. Well, we can't plug that in. We get 0 over 0, which is undefined. So let's start thinking about how we can break this down. Tangent is sine over cosine, right? If I could write today. And then we have an x on the bottom, okay, because that was already there. Notice that we have sine of x over x. Limit as x approaches 0 of sine of x over x is 1. So that cancels out. We have 1 over cosine x. Now can we plug in 1 over cosine of 0, 1 over 1. So the limit is 1. Next one. Limit as x approaches 0 of 1 minus cosine 2x over 4x. Notice that these don't match up. It looks very similar to this, excuse me, looks very similar to this identity or special trig limit, but it's got a 2x. The big thing that we need is we need these to agree. Whatever's in the parentheses here, we need to be the same here in order to use that special trig limit. Well, we could rewrite 4x as 2 times 2x. And now notice we would have 1 minus 2x over 2x. We know that part is 0. So we have 1 over 2 left. And then we know this other piece is 0. 1/2 times 0 gives us 0. Take a look at C. Limit as x approaches 0 of sine cubed over x cubed. Think about how we could rewrite that. That's sine of x over x all cubed. Well, limit as x approaches 0 of sine of x over x is 1. So this is 1 cubed, which would be 1. Last one. Notice that this looks like part of each of our special trig limits, but it's missing an x. So we could actually multiply by x over x, which is just like multiplying by 1. Then the sine of x over x is 1, and the 1 minus cosine x over x is 0, and then 1 times 0 is 0. Again, those are just limits you have to have memorized in order to be able to use them. Okay, last thing that I want to take a look at with you guys is limits toward infinity. Okay, we already learned these rules. This has to do with dealing with your powers. If you're bottom heavy, the limit as x goes to positive or negative infinity is 0. Bottom heavy meaning the highest power is in the bottom. Top heavy, you want to plug in a really big number using whatever sign the infinity is, and then whatever sign you get is the answer with infinity. So the only way with top heavy, you're only going to have a possible positive infinity or negative infinity. That's the only choices you could have. And then equal powers, you're going to divide the coefficients that happen with the highest power on top and bottom. So let's take a look. I've got one of each case. For part A, we have one where it's bottom heavy. Notice the highest power is degree 2, and that's in the bottom. So limit toward negative infinity is 0. We like those the best. They're very quick and easy. Next, we have a top heavy one, okay, because the highest power is 3 in our numerator. We want to plug in a really big negative number because we're going toward negative infinity and see what sign we get. Let's say we plug in negative 20 just to try to get a look at that in behavior. So if we plug in negative 20, think about on the top, we're going to have a negative number because negative 20 cubed is negative. On the bottom, 2 times negative 20 squared minus 1, that's still going to be positive. So we're going to have a negative answer. That means this limit toward negative infinity is negative infinity. And last problem here. Limit as x approaches infinity. We have, excuse me, equal powers. Highest power is 2, same in top and bottom. So we just divide the coefficients, which would be 4 over 3. Now notice we use the coefficients with those highest powers. So we're using the 4 and the 3 because those are the numbers with the x squared. All right, guys, I hope this was a good, quick overview of our limits properties and that hopefully you remember these all from last semester. We are going to have a practice assignment as well, so take a look at that and make sure you feel good about these rules.